Hello, so this is a tutorial on how to use the SIC MPU9250 the IMU compute module with ROS2. So this is a robot I'm working on, and this tutorial I'll actually be showing you how to use it with your PC, not a Raspberry Pi, as I've not fixed the Raspberry Pi yet. I'll be fixing it later. So to connect it to your PC, I'm going to be connecting it to, this is my USB port, which is connected to the PC. I'm going to connect that. Here I'm going to connect to the FTDI module. Yeah. Remember, it has to be calibrated. Just follow the tutorial on the calibration to ensure that it's calibrated and the magic filter is already set up. So everything has been done on this particular timing module. So with that being said, also you need to ensure that you have a ROS installed and your ROS workspace already set up. So I'm going to be using this repo. This is the link to the repo, and get it from the tutorial. So I'm going to be using this repo to set it up. So the next short video, I'm going to show you how to quickly set up this in your ROS workspace. The next thing is now to check the connection of the IMU, that is the MPU9250 IMU. So with that, there are two methods. You can either use it, check it via this serial by path or the DepTTY. I'm going to be testing that. So I'm connected to DepTTY USB 0. So I'm going to check. So this is my ROS package, which I've already installed. The SIC MPU9250 ROS package, which I've installed. So once I'm done, it said I should go to the config folder inside the ROS package. Now in the param file, I should change the serial port value to that which I've found in this step. So that's exactly what I'm going to do. I'm going to go into this in the config file. There are two param. There's the start and test param file. I'm going to open. So in this test param file, which is where I'm going to. So you see these two. I'm using the by path. I will commence this and change whatever port value I get here. But since I'm using the GTY 0, so I don't need to change anything. I leave it there. The same goes for this. I don't need to change anything there. I leave it the way it is. But if you are using the by path, please change. You will change this. Yeah, you will change this. Just take note of that. So once that is done, I can build the package. I don't need to change any of that and just build the package. Yes, okay, so since I'm in the Qualcomm workspace, I'm in my ROS workspace, the ROS workspace, so I'll build it in my ROS workspace. So once that is done, the package has been built. Yeah. Visualize with RB just for a test. We'll source the workspace, then launch this. Let's do that. I'm going to open a terminal here. I'm going to source my workspace. This is my workspace, which I'm going to source it. Then launch this. And you notice once I start launching, you notice it will connect with it. Yeah, it's connected. It takes about 10 seconds for it to start up. So once you notice it's already blinking, that means it's sending the data. And I switch here that IMU transform is being published on the map frame for test RVs viewing. So let me open my RVs tool. So now that I'm opening it, all I need to do is to add the TF data, to add the TF display, the transform display. So once I add it, I'm going to expand it, move it a bit here. So you notice now that it's now being published on the map frame. You look at the TF frame or the trees from the map to the IMU frame. Yeah, so it's being published on the map frame. That's exactly what it's doing. So if I should pick the robot and begin to rotate it, you notice. Yeah, you notice it's working. I think normally this is this grow heading position. So that's how you just set it up with ROS2. Just quickly run some ROS2 topic list. If you notice that it's publishing on IMU data RPY. So the IMU data is the normal IMU sensor data. You understand, which publish the quaternion and the covariances, while the IMU data RPY is just publishing the row, pitch, and yaw data. So if you prefer just to read row, pitch, and yaw, just use this. But if you want to go with the normal ROS2 standard data publishing, just use this. I'm going to ROS2 topic echo IMU data. Just, yeah, you notice. Let me just stop. You notice the data being printed out. It's publishing on the IMU frame, and orientation in quaternion is being read out. Now the orientation covariance is also getting the covariance in case you're using it for some advanced algorithm like extended Kalman filter. Also, it's publishing the angular velocity and angular velocity covariance. All these things, if you follow the setup process, see that a lot of all these things have been calculated already on the IMU. So that's why I said earlier that before you start this process, you need to have done the calibration and magic setup. That's why you do all this covariance, computation, and a lot of things. We did everything is being printed out. So I'm going to test on that topic, which is data RPY. So you notice that what is just printing is just a vector, rotation around the x-axis, rotation around y-axis, and rotation around x-z-axis, and it's being published on the IMU frame. That is what you need to take note of. So if you just need the raw picture and this is where you can get it. So that's just what it's doing.